Hello. So I'm going to go ahead. It's 6:30. Try to be prompt and start on time for the first time in our organization's history. So we're going to make it happen. So welcome to Toledo Codes. My name is Justin Beaudry. I'm curious, who's been to a Toledo or who hasn't been to a Toledo Codes event before? Okay. Has not. Okay, we have a few. Awesome. Well, thank you for coming. For the uninitiated Toledo Codes, we host these events every third Thursday right here at the Loft. We're trying to build the tech ecosystem here in Toledo, and by doing that, we're going to be hosting these events regularly. If you have a talk you'd love to give, you can go to our website, Toledo.Codes. We have a little link up at the top. You can submit a talk. Would love to have more of you folks out here giving talks. So first, a little bit of background on Toledo Codes. I first pitched this idea as sort of a meetup of meetups, right? Like we didn't, there was a few meetups. We had GDG Toledo, we had WordPress Toledo, we had Toledo Web Professionals, and I'm sure there are other, user groups out there. But the reality is that these user groups weren't really getting a lot of folks. So the idea was, let's get everyone together in one place. We'll have some technical talks. They'll maybe outside of your technical range. Maybe they're in your technical range. That's okay. Eventually, once we get enough folks in their particular user group discipline, we can split those off. But we got to start somewhere. So yeah. So what Toledo Codes is we're kind of all of those groups, right? I work closely with GDG Toledo. In fact, I'm a co-organizer of GDG Toledo, in addition to WordPress Toledo and Toledo Web Professionals. I'd like to thank our partner, the Toledo Tech Loft, and Chris Eischen. Without the Loft and this wonderful space, there are other places we could do this, but none quite so as beautiful and awesome. So yeah, well, thank you again for coming. A little background on myself. My name is Justin Beaudry, and I'm the Director of Engineering at Actual Reality Technologies and the Director of Technology at Empowered AI. So I've been writing software about 15 plus years. I'm a Toledo native. I grew up here in Toledo. I moved to Austin, Texas for a while, moved to Silicon Valley. I worked for early stage startups and enterprises alike. And now I'm back, and my goal is to help build this ecosystem in some way. So that doesn't happen alone, and there's no sort of hero complex about that. What I'd love is, kind of takes all of you out there as well, right? It takes all of us to do this together. And so if you're interested in helping out or you like to give a talk, come talk to me afterwards and let's go from there. So today I'm going to be doing a talk. Now I've had two forms of this talk originally. I came up with the title first because I thought it was funny, and then I worked backwards. And originally I was going to do this deep, super technical talk about multi-stage RAG and some of the advanced things we're doing nowadays with RAG. But I thought I'd dial it back for this initial talk. This will be about maybe 30 to 45 minutes. Keep it pretty casual. I had originally planned to do a live demo. Turns out that's a really, really bad idea. And the key is to pre-record your demos. I did not do that. So we will not be doing that today, but next time, right? So yeah, thank you guys again. And I'll go ahead and jump right in. So first question I have for you guys is, can anyone tell me what RAG is? Does anyone here know what it is? Jay?
Retrieval-Augmented Generation.
Yeah.
It creates output based on the data which you provide, like PDFs or database, and based on the query, it considered as an output context, basically. It creates a context based on data. It gives the output.
Okay, yeah, we got to have the mic ready for that one. Yeah, you're good. So what he said was that RAG is Retrieval-Augmented Generation. Effectively, right, when you query an LLM, right, you're going to get a response based on whatever it was trained on, right? And typically some of the model cutoffs are about 2024, right? That's the knowledge cutoff. Anything past that, we have to augment the model in order to tell it, exactly, to give it this additional information, to give it additional context, right? And, even though this talk is based on RAG, I'm going to emphasize quite a bit that context is your greatest friend and enemy when you're working with LLMs, in particular, because too much of it is a bad thing and too little of it is a bad thing. So there's kind of a sweet spot in there. And that's the fundamental problem with these things. We have hallucinations. That's a fancy way of saying the models lie, right? They just make stuff up. But this is actually a fundamental property of the LLMs, right? Because in order for it to be, quote, creative, it has to make something up. And without that, if we think about like old school search, like if I go to search for something, if I see no results, that's a bad thing. And what we figured out is that we at least have to show something. And models has this setting called temperature, and you might have heard of this before. It goes from 0 to 1. Maybe when it's 0, it's supposed to be not as creative and more grounded. When it's 1, it just makes everything up. It lies about everything, right? Now, in reality, setting that setting to 0 isn't actually setting it to 0, right? Because if you were to experiment and set that to 0, you would see very quickly that it's not as fun to interact with without being a little creative, right? And I mentioned earlier as well that the knowledge cutoff is the issue. In addition to just having, what if you have proprietary or private data that you want to chat against, right? And the other part is source attribution. At a certain point, we want not just groundedness, but we want to, I want to be able to know what it's saying is backed by something specific. And as I said in the slide, trust me, bro, isn't good enough for production systems. So what we have is RAG, Retrieval-Augmented Generation. It's very, very, very simple at its core. What we're doing is we're taking the query, we're sending that to a vector database where we have embedded documents. Now, those are a lot of big words. What do they mean? Well, vector databases are exactly what you think of them. They are they're actually vectors, right? In physics, a vector is, I think, does it have magnitude and direction, right? So it's the same exact idea. Some of these things have 15,000 dimensions, and they're effectively shooting a vector out and finding something within close range of that. Anything within this sort of ORT cloud around the particular vector that you shot is probably relevant depending on how you embedded that document. So when we, quote, generate embeddings, what we're doing is we're vectorizing, we're turning that into matrix. It's very complicated math that I'll be completely honest here and say that I don't fully understand. I understand 2% of it, and that's probably exaggerating even. It's very, very complicated stuff, right? But we embed these documents in these databases, and when we take your user query, we send it there, and typically you'll hear the term cosine similarity. So that just means we're looking to see, again, around that ORT cloud in your vector database, within this multi-dimensional space, any particular chunks of this document that match what you sent. So we retrieve those, we do this cosine similarity search, typically. We augment that, inject that into the system prompt, and then you generate as per usual, right? And you guys are all familiar with the term system prompt here? This is the instruction we give the LLM that just sort of, I like to think of it like I always like use the ORT cloud solar system thing, but it's like, the system prompt sort of gets the LLM in the range of the topics that you want it to talk about, right? And then, of course, it generates output. And I mentioned the magic is these vector embeddings, and I think I went a little too early there to discuss that, but it effectively converts that text into numerical vectors that capture the semantic meaning, right? And transformers were really the key to this. That 2017 paper, Attention is All You Need, by I believe that was Google DeepMind who wrote that paper. This was the transformative thing that gave us the ability to have semantic understanding embedded. Now, we still don't fully understand, right? If you train a model, we still don't really understand how it does it store the fact that Michael Jordan was a basketball player? No clue. We really don't know that. And there's still tons of research out there in these aspects. But vectors, embeddings transform words and documents into high dimensional space. And typically you'll see embedding models ranging anywhere from, I think this says 768 to 1536. There are models out there now that are going even larger than that. But I'll tell you right now, typically you're not going to need much more than 512, right, in terms of your dimensions for your embeddings. When we build a RAG system from scratch, and you think about it, it's very, very, very domain specific. So, for example, at Actual Reality, we are building several of these domain specific chatbots for organizations like SSOE, Owens Corning, Owens Illinois, NOIC, And we're building some of these glass expert bots. Well, okay, so a glass expert bot has to be trained on its corpus, which is the body of text that we're generating the embeddings for. Its body of text effectively is it's comprised of actual patents and technical documentation, right? And so the embedding model you choose is very important. So we chose Patents BERTA, which is a BERT-based model that's very, very good at generating embeddings for technical documentation. So we said you choose your embedding model. OpenAI has the Ada models. AWS, Amazon has theirs. Google has, Gemini has their embedding models. You choose a vector database. As I mentioned, that's the multi-dimensional space that we're using. PG Vector, I personally really enjoy PG Vector. That's Postgres's built-in vector database. Don't sleep on that one. There's Pinecone, Weaviate, Chroma. I think even Llama Index has a built-in one. And then, of course, the large language model that you're going to be interacting with. GPT-4, whether that's if you want to host that locally, you could use Llama 3.2, Mistral, some of these other models out there. There's tons of models. They all have very different performance characteristics. And one thing you'll understand as we get through this, I hope, is that evaluating the output of these things is very difficult, right? Because it's non-deterministic. Meaning, given the same input, we can have a different output. Testing that is very difficult. So you have to be very rigorous in terms of when you're making changes. It's like game design in a lot of ways, right? When you're making a game, you have to make small iterable changes and then test that change. It's the same thing when we're working with large language models and we're using RAG. So first of all, we've mentioned a whole bunch of big words, and we've talked about embeddings and vector databases. Well, how do I get my documents into this multi-dimensional space? You do that by processing them, right? You chunk them, meaning you slice those up, and you could do that via tokens, so that could be parts of a word or a word. You've all probably heard the word token due to now we're in a token economics future, whether we like it or not. And you can chunk it in lots of different ways. But when I mentioned earlier when I was talking about how we make our glass model, you have to be very, for example, with patents, you don't just want to cut it off in the middle of a figure or a table, right? That would not be great. So you have to do it in very smart ways depending on your domain. So this is different depending on the domain that you're in. And as the slide says, you chunk it into manageable pieces, respecting the document structure. Again, this depends on the domain space you're working in. And you store those embeddings and the original text in the vector database. And then when the user asks a question, you're using the embedding model, you're doing a similarity search to find those relevant chunks, augmenting the context, and then generating the output. It's that simple. Now, you will find that there are a lot of different ways to do this now. So, even for example, I mentioned that you take the user query and submit it. Well, now we can do things like, we could take it to a small model, right? Like a GPT-4 mini, and we could say, give me, let me take this user's query and let me rewrite it depending on, the technical space that we're in. Maybe we can generate a better question that will get something different. Or we can even do that and do that multiple times, right? We could do 14 different user queries and then bring them all back in together, right? So there's query rewriting. There's, so we can do this. We can make multiple requests against the vector database, rewriting that one user query, right? Maybe I said, what's the company policy for what's the dress code on Fridays, right? Or something silly like that. Well, if my corpus of documents in my vector database has the company handbook in it, we're sending that exact request to the vector database to do the similarity search. And really, the secret to this is in optimizing is, as I mentioned, is chunking. And there's lots of other little keys here you can do, like simple things like caching, right? Like you could put Redis in front of a user request and cache the user query and cache the output response, and then instantly respond within sub 10 milliseconds, right? Like instantly. Little things like that. And you may end up having lots of different questions. So for example, you might have predefined user queries. Well, why not cache those responses, right? Those very, very simple stuff. But let's talk about chunking. I'm getting ahead of myself. Let's talk about chunking. So I mentioned you don't just want to split on tokens. You want to respect the structure of the document, meaning we need to think about paragraphs, sections, semantic units. The other part of this is like I discussed, well, how large of a chunk do you make? I typically will just do 512, but it's very dependent on the domain once again, right? I've had good success with doing a little bit smaller than 512 with the technical documentation and having a larger chunk overlap, meaning we have a little bit of overlap in the chunks that we're generating. That can work pretty well. I think around 15 to 20%, 10 to 20%, depending on the domain you're in. And again, document type, so code versus prose, those sort of thing. The other thing is that let's not forget about keyword search, right? Keyword search is still powerful. And we could do a BM25 keyword search with embedding similarity, and then weightedly combine those to sort of improve the recall. And you can see on the right here, this is an example of a system prompt we can use. It says you are an assistant with access to the following information. Answer only using this context. If you don't know, say so. That's an important life lesson right there. Never make up information. Always cite your sources. Here's the context. Here's the question, right? Pretty straightforward stuff. Given all of that, let's talk about what do we do sort of, and I'm moving through this probably way too quickly, but we'll go from there. What sort of production considerations do we have in this, right? Typically, you're probably using one of the large model providers out there. You're probably interacting with OpenAI, Anthropic, Mistral, Grok with a Q, Grok with a K. There are lots of them out there. And those are what we call inference mode models, right? Like these modes are running in inference mode, and they're very difficult. These are expensive to run. And I think we're starting to see some of the token economics shenanigans take place right now, right? Like, I don't know if any of you have played with something like Claude Code or Claude itself. I played with Claude Code for 15 minutes the other day, and it was $90. So, yeah, it's fun stuff. If you like spending money, use Claude Code. So again, our production considerations have to be, what models do we choose? And we're sort of recapping here a little bit. What models do we choose? Domain dependent. What vector database do we want to select? Honestly, PG vector is great for playing around locally. It's great for deploying. But I've really enjoyed working with Llama Index's offering. I highly recommend their offering. It's fantastic. They have a parse, extract, and index tool that are great for just getting something working really quickly. Don't make the mistake like me and put it on the most 90 tokens per page and spend $500 on generating embeddings for 200 documents. So there are a lot of economics that even at play here. Yes, that actually happened. And there's a lot of economics that happen here with these things these are a lot of considerations we have to have. In addition, another aspect of RAG that we have to think about is metadata, right? Because Llama Index is a great API for this, but so do the other vector databases. And giving it the ability to say, if I can filter by these particular aspects, just gives you that more fine-grained searching capabilities. And I mentioned earlier, I missed that I got ahead of myself a bit, but caching is very important in these aspects. You will be surprised by how often somebody will ask the same question. In particular, with some of these expert chatbots that you might come across, right? So I mentioned we're making Glass expert chatbot. Well, by caching some of the users' requests in Redis, like I mentioned, you can see a huge, probably 60 to 80% reduction in use of that particular of the hitting the vector database when you do that. Again, I think I'm flying way too far through these slides, but we're just going to roll through it. As I mentioned, this talk may be pretty short today. We'll see. And I hinted at this earlier, but this is probably the most important aspect of working with LLMs. Context window optimization. Context management is huge. As it says here, attention dilution. So more context can actually mean worse. And if any of you, has any of you tried like Cursor or Windsurf, any of these sort of vibe coding tools? Can I see some hands? How many? Let's see. Okay. And have you worked with it and you've played with it for a little bit and it works fantastic, and then on the next request, it's like it doesn't understand everything it just did, right? This is context window. These are context window issues, right? And it's very difficult. In the background, half of what they're doing a lot of the times is they're just summarizing, right? They take it to a mini model. We summarize all of the output we've had previously, and then we use that as context. But when we do that, how do we know that it's missing, that it didn't, it doesn't hide away some important detail that we actually needed it to know? The other aspect with this is cost implications, right? Like, as I mentioned, token economics are the future right now of working with large language models. And you pay per token, right? It gets very, very expensive. If any of you have worked, I mentioned Anthropic. Anthropic APIs are very expensive. They're very expensive. And in addition, latency issues, right? More context means slower responses, right? And the context window is growing. So some of these, they have 1 million token windows, but that includes input and output tokens, right? So you have to be mindful that both your input and outputs are sharing this, this limitation that you have, this currency that you have. And so you can optimize this. So for example, in one of the Glass Expert chatbot that I mentioned, we use something called re-ranking. So we'll do a top case search, meaning we're going to look at the top 100 documents. We do a little query rewriting. We do a little query spreading. We spread it out. We grab 100 or so of these documents, and then we re-rank them in order to basically assess what's the relevancy of these things. And then we filter that down to the top 8 and then surface that to the user. And that gets into sort of that compression, summarizing before including it. But a lot of this, everything I'm saying here, this is the really difficult part about this. This is the bleeding edge, right? Like, this stuff is very new. It's very, very difficult to evaluate, and you have to be rigorous and scientific about it. So I've found, for example, I mentioned we make a glass expert. Well, I don't know anything. In particular, this was a glass melting expert. I know nothing about glass melting except that you need heat, right? I know that you need heat at some point, but I'm assuming a lot more to it than that, right? So I have to rely on a subject matter expert to basically, I have to work closely with that subject matter expert to make sure that I am getting the right responses, right? It is outputting, it's giving them an answer that's grounded in truth, and is useful. Because I'm sure you've seen articles already talking about how, these chatbots aren't useful. Well, that's because they're not managing their context window. They're not doing some of these more advanced techniques. Yeah, we could all whip up a simple RAG chatbot literally in 5 minutes. We could probably have Claude do it right now, and no problem, right? But that's not a production solution, right? It takes a little bit more than that. We have to evaluate and monitor. And there are lots of great tools. There are tools. I'm sure you guys have talked about. I'm sure you guys have heard of tools like Crew AI and some of the LangChain, LangGraph. I really like the LangChain, LangGraph ecosystem with Langsmith. It's a great ecosystem, but you don't necessarily need that. You can use one of my more recent tools I've learned about, something called LangFuse. But effectively, what we need is observability. I want to see what's happening inside of there, right? And this gets a little tricky when you're dealing, if you have to have, if your system needs to have data encrypted in transit and at rest, right? That gets very difficult to start reasoning about how do you observe a system where your data is encrypted at rest. But we do this by looking at different metrics, right? Are we finding the right documents? So precision and recall, right? And we can do this through something called mean reciprocal rank. In addition, we can look at the sort of metrics for generation, right? Groundedness matters, right? Like, how truthy is this statement? So that gets into sort of hallucination detection and factual consistency. And there are lots of ways to do this. I personally will still exclusively rely on humans to evaluate that. You can use LLM as a judge, and that's a good metric to start with, but it's not a good metric to ship something to production with, right? You don't want to ship something to production using another LLM, using a non-deterministic system to evaluate a non-deterministic system, right? Like, you're It may work out, but likely it won't. And the other aspects, of course, when we're developing software, is understanding, we still want to have typical product analytics, right? We want to understand how satisfied are users with the output responses. You can typically tell this by how often they use your tool, right? Users come back and are using your tool. That means it's obviously giving them response, giving them something that they want, that they need, and they're going to continue to come back. If they ask a couple questions and they drop off, likely the tool isn't doing what they want it to. And most of the time, users aren't going to tell you this, right? They're not going to just come and tell you, well, some of them will. I'm sure we've all met a few of those in our working environment. There are lots of outspoken people. And I did get it in 26 minutes, so it's going to be a shorter talk, but we'll leave some time for questions. And this is the topic I actually originally had planned to talk much more about. But the future of this isn't just, we mentioned all these things, right? I mentioned the vector databases, generating embeddings, but there's also a lot more to this, right? We've all heard of graphing databases, Neo4j. GraphRag is the next generation of these models, and it's already out there, right? Meaning, how do we embed relationships into these things such that when we query, it can have those understandings? Well, the tricky part with GraphRag is it can be very expensive. If you have a lot of nodes in your graph, it can take a while, sometimes a little bit longer than you'd like, to traverse that graph. And so now, crazy enough, the next generation of this is something called lazy GraphRag, or effectively generating a graph ephemerally, right? So it only lasts for a brief amount of time based on the context of the information that you've got. It generates this graph, and then we can gain some understandings from that. So the real key takeaways here from this, and I'm very much breezing over this very complicated topic. We could probably talk a while about it more if I were more equipped with understanding of these things. So this is probably a talk in and of itself. So I'm not going to deep dive into that. But the key takeaway from this is that there are lots of ways to do RAG, right? I mentioned two-stage retrieval, where you're grabbing 100 documents, you re-rank them, and you fiddle it down to the top 8. I mentioned graph. We can have graph databases. So there are lots and lots of ways to do these, and I'm sure there will be more innovations in this aspect, because this is the thing that we want, right? Like, when I think about in terms of, this is the thing we want in terms of when we're interacting with large language models. When I think about what I want out of an LLM, I want it to give me an answer that I can trust, right? That's what we all want. This is the way we get there, right? I of course do not think that the transformer model is going to get us to AGI. We can have that. I'm happy to have that debate with anyone. I firmly believe this is not the path to AGI, but it is still a very, very powerful tool. Do I think it's going to change the world? Yes. Do I think it deserves the hype it's getting? In some ways, yes. Maybe it gets a little too much, right? And there's a lot of garbage out there. And speaking of that, actually, I'm sure you guys have all heard the term garbage in, garbage out, right? So I mentioned that you can give it documents, but what I never actually talked to you guys about, and it's not on the slides here, is how do I select these documents, right? Like, do I just give it 100, 200, 10,000, 20 million? The answer is you have to give it high quality documents, right? You have to handle, like, for example, with patents, we were like, well, how do we know that a patent is high quality? I'm not a subject matter expert in glass melting. We just went by how often that particular patent was referenced, right? That's probably an okay indicator, but it might not be, right? And so we have to rely on our subject matter experts in these particular domains to help us select these particular things. And so the answer is, as software engineers, we have to, much to some of our chagrin, we have to work with others and collaborate and have conversations about, the particular domain you're working in. And RAG solves these real problems. It solves the fact that LLMs lie to us. It solves the knowledge gap, and it solves attribution. And through our own experiments, at Actual Reality, we found that when I give a citation to a particular document, it definitely gives me that much more confidence in the tool, saying, I got that information from here. Here's where you can read about it. And I definitely think all of the foundational models are going to be incorporating something like this in the future. This is definitely going to be something that they'll do. But like I mentioned, this, some of this RAG is very accessible. You could build it in a few hours or even a matter of minutes. Mentioned earlier, chunking. I talked about, the chunk size matters, chunk overlap. And I will tell you generally, again, I'm going to repeat this again, 512 will suffice for most of what you're trying to do with a 10 to 20% chunk overlap. And you can experiment with it, right? Just take 20 documents, go to, write up a Python script or Go or whatever your language of choice is, embed those documents into PG Vector locally, and just try it out using a llama locally. And you can start seeing and measuring it, hook up Langfuse to it, add some observability and watch what it's doing. And you can really start getting some measurable ways to understand the quality of your responses. And that's where measure, monitor, and iterate are really, really critical with these tools. Yeah. So I mentioned I was going to go through it quickly, and I did. I did it in 31 minutes, which is better than I thought it was going to be. I thought I was going to go in 15 minutes, how fast I was talking. So it's going to leave time for anybody have any questions? Yes. Yeah, we are live streaming this, so yeah.
Cool. Yeah. So with the like reg setup, and you kept referencing like document retrieval and kind of like subject matter expert. Like you're making an expert bot. But like, let's say you're training it on a set of data. Like from a pattern matching kind of strategy, like I've heard of many different types of like pattern matching strategies and like whatever else. I've been doing a lot of research like in the space. It's like, do you just have to kind of like lean into that more to kind of understand like based on what your content is and like what you ultimately want your result is, and maybe to your point about testing the responses and getting this kind of feedback loop to kind of come up with like what the best type of kind of methodology you're going to use like within like the RAG system to get back what you're looking for, to like start looking at patterns and trends, and like how does that differ from like kind of what you're talking about is like document retrieval and things?
Yeah, I mean, effectively, when we think about like a cosine similarity search, we are really looking for patterns in the documents, right? So yes, I think you will. I don't really know of any more advanced techniques at top of mind, right. But as I mentioned, your quality of documents matters, and really it's about that iterating through it, monitoring, testing, and iterating to see and testing that response output to see what you get, and really, come up with a set of 20 questions or 100 questions, or probably I would start with at least 20 and make a spreadsheet and test the output from that, and come up with some form of rubric. Right. And you can use that yourself. LLM as a judge can help you with that lightly. You can get some evaluation from that. You can even train. You can even, we can still use things like Spacey NLP libraries to do some of this, right? There are a lot. NLP is still fantastic, and we can use that to even, have more grounded understanding of what our output quality. Does that answer your question?
Yeah. No, I mean, I think just like from a research standpoint, like what I'm looking to do is ultimately, kind of like narrow down like, more of a strategic path around like if I was going to start like into this space to start iterating on, like product idea, that, like where I'm going with it, I'm not like, missing the point like completely. So, it's just, I'm in early stages of kind of doing this research.
Yeah, it's really going to depend on what you ultimately want to do with it, right? And that's what it's very, very domain specific. But generally, if you kind of stick to the strategies that I mentioned, you'll get good quality output.
Yeah, that's cool. Do you have your slides available, or
I'll
give you my email address?
I publish them up on the site. So they'll be published on the site later on tonight. I'll make sure they're published.
Yeah, I just like lots of little, acronyms and different things. I like
there's a lot of nuggets I didn't dive into of each of those words. Probably we could have talks about.
And then from like an MCP server standpoint, like what type of relationship does like where's MCP sit like within like RAG, like as part of the ecosystem? I mean, like
Totally separate concepts.
yeah,
right.
right.
MCP is a protocol for abstracting tool calls. So for the uninitiated, tool calls are effectively ways that we can say, I want to give my LLM the ability to interact with Salesforce or some other tool and use their APIs to query it using natural language and do that in a sort of structured way. And I personally love it. My Claude, I have like probably 50 MCP servers hooked up to it.
You talked about Neo4j. I was like, I'm keeping my context like from an MCP standpoint through there. So like we're continually updating the memory, creating relationships, and then if you go from like a task, create plan before you jump into actually doing development. There's a couple like really great MCPs for setting up like a really good workflow.
Yes.
And so those two things kind of go hand in hand to keep your context window small and focused. And I found like with Claude, it really helps.
Agreed.
With the bill.
Yeah, agreed on that front. Yeah, and I use I have a custom MCP server with an actor critic model to sort of reflect, I use the sequential thinking, I use memory, which uses the graphing database. Now Claude has memory, which they just introduced finally. But yeah, I'm fully invested. Like we use Linear to do our engineering tasks, and I am that's how I interact with Linear. As I tell it, here's my ticket, here's the acceptance criteria, and then you have to obviously go read that because it will often make up stuff, as my engineers have found in some of the tickets when I miss them. But yeah, thank you.
No, thank you so much.
Any other questions? Yash.
So, to me, what stood out most what was most interesting to get a deeper dive into would be caching. Are there more proprietary caching strategies and techniques for data retrieval for a RAG system, or is it?
Yeah, absolutely. You could do, I mentioned you could do simple text matching, right, with just taking the particular query and going to Redis with that. But you can also do cosine similarity caching, right? Like you can also use those algorithms to do caching as well. Meaning, I could take something that's semantically similar and cache the output response from that, right? So that gives you even more cache hits, which is that's really the true unlock. Now, I haven't shipped a production system that does that, but it's definitely a really, really interesting concept that I think will be important in the future production RAG systems.
I see. Okay. Anybody else?
When you get your data, like from a PDF, is there any particular tools you use? Do you just like grab the text straight from the PDF, put it into Markdown? Do you use the OCR, which is a lot better, but a lot more expensive? Do you have any tips or tricks?
It's funny you mentioned that, because this was the original talk I was going to give, which is much more technical, and it gets into cross-encoder ranking, practical chunking. I mentioned this earlier, talking about semantic search. If we have an exact search, we can return from Redis. Mentioned some of that earlier. And your question, repeat your question for me one more time.
Like extracting data from PDFs.
Yeah. So this was what I was going to pull up. So this Cal Poly, actually, I just found out about this pretty recently. You can actually generate embeddings right from images, right? So you don't even necessarily need to. Typical strategy is to OCR, yeah. So typically the way I do it is I use like PyMud PDF or PyPDF or something like that. I'll convert the PDF into Markdown, and I'll generate embeddings straight from that, right? That's my typical strategy for it. Truthfully, I've not experimented with this yet, but I definitely am going to be, because I thought it was really, really, really interesting. But yeah, that's my typical path. And I'll tell you, Llama Parse, I mentioned this earlier, makes that very, very easy at scale. It works fantastic for some of the tooling we've done at Actual Reality. And they have a great extraction library tool that will use something like, because you can do a mix of you can do some OCR, combining that with an LLM to do some inference on that, and you can get pretty good output from that. That's like my typical go-to.
I have another question.
Yes.
Somebody who implements RAG systems, how much math do you actually have to get into, or any at all?
It's a good question. I think
Was the question the truck kind of wrapped up?
Oh, sorry. I asked, is somebody who implements RAG systems, how much math would that individual have to get into?
most of it is abstracted away. I'll tell you. Most of that is abstracted away from you, and typically you don't have to unless you're doing something really advanced. I would say it's probably a good idea to have some understanding of that, but on a day-to-day basis, we're not typically doing any vector math or anything like that, anything crazy.
Gotcha. Any other questions? Down here. Just want to pass it.
How much monitoring do you do after production? Do you capture user queries and the responses from the system?
It's very dependent. So for example, we have our expert glass chatbot we built at Actual Reality. That has to be encrypted in transit and at rest. So in that case, no, right? But in a typical system, I will to some extent monitor some of that. I really don't like to just store the user queries. I feel like that is kind of private information at some point. I think we have to treat it as such. But in terms of observability, definitely having metrics and understanding your response times at every section, between every service that you're using, right? You're like, how long does vector database retrieval? How long to cache? How often am I getting cache hits? What's the response times from that? So you definitely should be measuring all of those systems in addition to any sort of product analytics you're doing on that.
Are the cache hits, are they per user?
You could do it. You could do it sort of in a multi-tenant situation, but it really depends, right? If you're delivering a multi-tenant application, then probably yes, because it just really depends. I could see a world where you could share some of it, right? If somebody asks a particular factual question, and then probably we could just use a cache hit for anybody globally. But it's really contextual to what your application does. And so, for example, if I were to have a particular expert chatbot like we have at SSOE or NOIC, yes, I would make a global cache, right? Because they're all sharing the same sort of corpus of anyways. So of course I'm going to utilize that. But if I were to say ship like a ChatGPT or one of those like solutions, like let's say I want to deploy the next Claude, I might not do the same thing there, right? I might generate it per user just because of memory and other aspects that can augment that.
Okay. Does the company get to update their own corpus?
So again, dependent on how you build it. So for the applications we build, we set up an ingestion system so it's easy for them to add additional documents. Those are available, right away. You have a data pipeline that's ingesting those documents automatically, OCRing, generating embeddings and doing that. And then 15 minutes or so, you can have a few, dozen documents embedded and available for search for your users.
Hi, I'm sorry, this is really simple, but you mentioned a vector something that had 15,000 dimensions, and just simply, I can't imagine 15,000 dimensions. What are they?
They're literally, Louis, you want to?
No, so Matt, Morgan's previous just kind of piggybacking about what you said. So vectors are free. That is just semantics and some understanding their steps. So as you increase the resolution, you're also ensuring that you're capturing some more of the actual meaning of the right. So just this point, you can chunk a document in specific ways to cover multiple vectors for one document. Or if you want to, you can build an entire document and create one large vector. You reduce a lot of that dimensionality and resolution that you need to actually understand. So the best way to think about it is on this side of things, especially with the chunking strategy, biaswell, 768, those are going to be your comfort zone. But as your chunking strategy becomes looser, you probably want bigger, larger vectors, make sure you maintain some of that.
And to also jump on your question there, I don't think I could visualize 15,000 dimensions, right? Like, I don't know if you guys have read like the 3-body problem when they start talking about like 2 and 1-dimensional things and the 1-dimensional photon. Like, I can't really wrap my head around it, and I really can't even visualize the fact that the 4th dimension is time. At a 15,000 dimensional space, it is really sort of unfathomable to think about. It's like thinking about the scale of the universe. I really don't know that we can wrap our heads around it, but it is exactly what I described it. It is just that, right? We have 3 dimensions here in our physical space and time, and yeah, it is just that. Very complicated to think about. I do not understand it, but I'm glad that we have people out there who do. Maybe, yeah. Again, yeah, they might not, right? We're still like, this is all cutting edge. We like I mentioned earlier, I think I got that from 3 Blue, 1 Brown or something like that. Highly recommend his YouTube channel, by the way. I think that's what it is. Is that what it is? Are you guys familiar with that? Fantastic YouTube channel on visualizing all these things I'm describing. And he, very smart guy, explains it in a much better way than I do. And he can even dive into like how attention layers and how the transformer model works and what the 15,000 dimensional database looks like with some really pretty graphs and all kinds of stuff. Cool. Any other questions, thoughts, concerns? Awesome. Well, I think we did 46 minutes. That's not bad. I'll take it. I'll take it as a win. Yeah, thank you so much for coming. Again, we do these once a month. So, I'm seeing new faces here. I'd love to see you guys come out for another one of these events. Now, next month, we are not going to be doing a Toledo Codes talk. We're actually going to be launching something called the AI Collective. We're going to be doing another meetup that's more around AI for everyone. Myself and a few others are going to be leading this chapter. We're going to be doing this we're actually going to be hosting at the Toledo Museum of Art. We're going to try to make it a little bit larger of an event. We're going to have a panel discussion with experts in the area. And our lens that we're looking at this through is groundedness in AI, what like hype versus reality, right? And that's the lens that we're looking at it. So we're going to bring in some industry experts from the region in our particular domains, manufacturing, healthcare, et cetera. We're going to have a panel discussion. We're going to have some food, and it should be a fun event. We're going to do that next month, October. Oh yes.
So that is more for me.
Correct.
Okay.
That's for everybody. Yes. Yes, and we're going to be doing those events. We're going to be doing more of those events. We're going to be doing some interesting stuff with that, where we might partner with TMA to do some let's generate some AI art. So the sky's the limit, right, with these things. And this is really a part of what we're trying to do regularly here. October, we're going to be participating in Hacktober. So we're going to be doing some bug hunts. We're going to get together, dogpile on a particular open source project and start fixing issues. And hopefully what happens is somebody goes, why are all these people in Toledo fixing these bugs? And that's our goal, right? Let's make it happen. So this doesn't happen without you guys here showing up. So let's go ahead and give a round of applause for everybody showing up here. Thank you for coming, because this is how we build a tech ecosystem, right? By showing up, eating pizza, and hanging out. Yes, Keith. Thank you for that. Yes. Also in November, we are hosting what we hope to be the largest AI conference in the Midwest. That is Great Lakes AI Week. That's going to be hosted at BGSU. We hope to have ancillary events around the town. So if you have ideas, you want to do a workshop, something like that, come talk to myself, Keith. There's a few others. GreatLakesAIweek.com is where we can do that. Greg, Vajish as well, or Vajish, Yash as well. Got a little GDG mix up there. But yeah, so very exciting. We're really excited about all this stuff that's happening between Toledo Codes, AI Collective, Great Lakes AI Week, Code Mash in January.
So there's going to be a Google developer group, DevFest, in Detroit on November 22nd.
Thank you.
And we're all going to be there. So I can't wait to see you. Being put together with some great people. They want to have 1,000 people there. So you're going to have a chance to network a little bit, probably. They're going to do it at the Motor City Casino, I think. You guys remember that place? Kind of a big place, but
Yes, thank you, Greg. I completely spaced on that, and that's going to be a big event. And you know, the other aspect to this is like it's great to show up here, but we also have to start showing up other places, right? Like we had Toledo people have to go to events in Detroit, Cleveland, and Columbus, so that you know they can reciprocate, right? Because we're not going to get people coming to our events unless we start going to theirs. But yeah, I would love to see you guys out there for those events. Keith. Yes, that's another one. That's next month. Myself and actually Lewis Lane back there in the back are doing a talk at in Columbus AI Week. I think that's September 9th and 10th or 10th and 11th. One of those. What is it? Thank you. Thank you. So the Columbus AI Week as well. So lots of interesting events going on in the region. Hope to see some of you out there. Is there anything else we're missing? Because I feel like I am. I did briefly. I just said we're doing bug hunts. We're going to be doing, we're going to work on open source projects, TBD, you know, of course, we'll figure out like whatever anybody wants to do. We can kind of figure out what that is. Maybe even potentially do a week of spaceport. You know, that's Jeremy's framework that he built in Groovy. So yeah.
Batting cleanup.
Oh yeah. Yeah, we could talk about batting cleanup. So Toledo Codes, you know, we're doing these meetups, but we have another initiative that I'm super, super excited about. So we started we started a student organization, thanks to Yash, and you'll see some UT students around here, that we started a student organization at the University of Toledo. And what we're doing here, the goal of this, right, because I think we started with the talks, and then I kind of realized we have a chicken and the egg problem. In order to build a tech ecosystem, you have to have people here who are technical. How do we do that, right? So our goal was that we're going to start student organizations. We're going to go to UT first. We're going to go to BG, Defiance, all around the area. We're going to source projects from local companies, nonprofits. We're going to effectively do a little bit of a mentorship program, bridge the gap from college to professional software writing and how we do it at scale. And then sort of bridge that gap. The students build the project. We deliver it to the client. We do it all in public. We record it, put it on social media. The students get a huge benefit from this, right? Because not only do they bridge the gap between their skills, they learn how to build software, but they also build in public, which, as we know, this is a very important aspect when we're hiring now, due to the fact that we can AI generate most of our code, right? So you have to have some of that social proof. And so as a part of that, we, Michael Vanderpool, who some of you may know with Anthony Wayne Design and Innovation, came up with this project called Project Batting Cleanup. He saw some overflowed trash cans during the Mud Hens opening weekend and said, what if we could have a simple solution to scan QR codes, report overflowed trash? It started with that. He met with Adam Casey from Keep Toledo, Lucas County Beautiful. We partnered with them, Connect Toledo, Downtown Toledo, and TARTA, and the city of Toledo to basically create an application. We're going to put these QR codes in trash cans throughout the city. We're going to put it on bus stops with the idea of keeping Toledo, Lucas County beautiful. Building an application that they can scan it, report it, get a little dopamine hit of I did something socially good, right? And some of these students are going to be participating in that. We're kicking that off in September. And then we're doing another project we're going to be rebuilding the Toledo Free Press website and mobile app. We're going to continue this. And I'd love to see, we definitely need help if anyone's interested in mentoring. If any of you are professional software engineers, do feel free to reach out. Or if you're just doing it for fun, reach out and talk to me. There's lots of ways we can help each other. So that's Project Batting Cleanup, another aspect of Toledo Codes. And with that, I think that's it. Any questions around any of the events that I've discussed? Cool.
Please take pizza home. Help clean up on our.
Jeremy.
Exactly.
Thank you. Thank you much. Thank you for showing up. That's really the important thing here. All right, so I'm going to end the stream. Looks like we did almost an hour.